Okay, so today, one of the things we want to do is look at some of the excerpts in your book, and with that, we will start on page 387. Okay. We're not going to spend a whole lot of time on this today, because as we all know, we're all busy with this. And I wasn't even thinking when I had made that schedule up. Shoot, I handed that out yesterday, and I had meant to hand that out today. So we're going to give you plenty of time to work on that, because I know, especially for you two, we're extremely busy these next 3 days. Okay, not just today, but especially again for you two tomorrow and Friday. But one of the things that we see on page 387, where it's talking about, it says writing equations for dehydration of alcohols. Now, one of the things that I wouldn't say I disagree with the author, but what happens is really when you add these, it's the temperature ranges we talked about yesterday that will determine what types of compounds these will form. Notice they say just writing equations for the dehydration of alcohols, Roman numeral 1. So if there's going to be a Roman numeral 1, obviously there's going to be a Roman numeral 2. And that's what we'll get at today. But as a review, we're going to do a little bit of a preview here. Okay? And it's based off of this information that we see here. So letter A that you see in example 13.7, okay, what compound do you see there? What are we reacting? It's an alcohol, but what's the name of that alcohol? And is it the condensed molecular formula that's maybe a little confusing as we're looking at that? Because we're so used to seeing this, okay? Because in your book, it's showing you this. And then I'm guessing, oh, they got a dash there, don't they? Yeah, CH2, then showing you that OH. These mean the same thing. So you're probably a little more familiar with that. So what compound do we have? Not only just an alcohol, but what is it? Yeah, it's propanol. And then what the author does is they have the arrow here, and maybe that's how they teach that in college chemistry. Because one of the things we do, I prefer to show that instead, okay? Or in college, is this possibly?
All 7 through 12 students, please check your email to vote for tomorrow night's theme for the volleyball game. And please do it by noon so we can get the votes tabulated and recorded. Thank you.
So regardless, get your options in for voting for tomorrow night's theme. So this is what the author shows. I think it's an arrow, and it has, yes, H2SO4. That's how you do it in college, okay? So keep in mind, this means the same thing, because I think we're just so conditioned, and for myself at our level, okay, which to me, maybe this is a higher order of looking at this. To me, it just makes more sense for me to help yourselves out by writing it like this. So you might encounter something like that in college, but it means the exact same thing. Okay, so what happens with this, though, is it's going to depend upon what your temperature range is. So we're just going to keep it consistent with what we had learned yesterday, okay? Because what happens at 180 degrees or higher, okay, we know that what type of reagent do we say this was yesterday? We only said it. I don't think we wrote it down. Starts with a D. Yeah, because you got that. I'm not even going to try to tackle what color of a mug that is. Blue and pink.
Where are you getting
I don't know. Okay, it's the lighting.
Okay, it's like dark.
Okay, purple, whichever. Okay, purple and pink. Okay, we got that established now. Okay. So inside of there, I hope it's water in there. It could be Diet Coke. Could be chai tea. I don't know. What are students drinking nowadays, Mr. Wagner?
Coffee.
Okay, is there coffee in there? Oh, okay. All right. Oh, well, whichever. Okay. So notice to make sense of this, this is what you learned almost said last year. Okay? Okay? Because we said this is probably one of the most, okay, important industrial reactions there is. Because this is giving you your isopropyl alcohol or rubbing alcohol. So what this means is, look at what are we adding? Water. So that is a hydration reaction. So then what we mean by this is if we're adding this H2SO4, which gets extremely hot when you put that into a liquid solution, and if it's at this temperature range, the opposite of hydration then is dehydration. Okay? So in this case, we're writing plenty big that you can see on here, and we're running out of room because of this pH scale. So we're just going to put the product over here. And to make sense of that, okay, if it's dehydrating, what does that mean to you? What are you losing? Well, yes, that's true too. You're not only just losing this, okay, you're also going to lose an adjacent hydrogen. So that's why we're putting boxes around there. So now what we see happening here is your new product, okay, and then like yesterday, I'm just going to do this box is taking that bond with it, okay? And that box is taking that bond. So all these are still here. And what we said yesterday, what's wrong with this cup? Well, for one, it doesn't have any bonds yet, but what does it need? It needs 2 bonds. So notice that one of the things we want you to think about is alkenes are hydrated to alcohols. Okay, then alcohols can also be dehydrated, Gesundheit, to alkenes. Okay, so that's what you would see happening here. That's not the only thing that happens, okay, because later on we're going to talk about that temperature range. When it's lower temperatures, it forms a totally different compound, okay, but that's for another time and another place. Okay, this is where we left off with yesterday. Okay? Any questions on that? Okay? So also yesterday we said probably the most important aspect to recognize when we see these is what type of alcohols they are. So we're going to keep it consistent with this. What type of alcohol do we have? Yes, it's propanol, but that doesn't explain what it is. Okay? That's why we got these close. That's why we still have these letters up here, because what happens is when you add something like this, that's 1, okay, and that's another. These are what we call really, really powerful oxidizing agents, okay? So what that means is they're going to be placing an oxygen on here. Okay? Oxidation is just the exact opposite of reduction. Because when you reduce something, you're reducing the charge by adding hydrogen. Okay? Oxidation, just think of it, you're adding oxygen. That'd be a good way of looking at that. Okay? So in this case, okay, I think it's worth our time to, per se, go through the example and then talk about the example that's in your book. And this goes through what we call 2 stages. Okay? In stage 1, this is only happens with primary alcohols. This gets oxidized in what we call stage 1. Okay? And then what we see happening then is this also gets stripped off of here, okay? And we arrive at that, okay? So it's not completely the same. I should probably just erase this. What we're gonna wanna be able to do is just recognize what's actually happening, okay? So we went from a primary alcohol to what here? What type of functional family is this? Close. It's an aldehyde, okay? And then this goes through another stage. We're going to call this stage 1. And then because these oxidizing agents are so powerful, I'll just pick one. We're going to call this stage 2. And then what happens is the best way to describe this and why this happens is this was one of your essay questions on your exam. Okay? If you're going to make TNT, which chemists will do making these explosives, okay, you all had correctly explained you have to make toluene first. Okay? Because what type of director is an alkyl group? Is that, what was that from prior knowledge? It's an ortho and para director. So when you're reacting with that nitric acid, okay, that means here is one of your products, okay? There's your ortho group. Then where is your para group? Straight down on the bottom. NO2 is down here, okay? And then if you have that excess nitric acid, that just means this keeps on going, keeps on reacting, which means the only thing that's left, you could look at it one of 2 ways. This has been used up because you already made your toluene, but you can look at that nitro group or that nitro group. What type of director was HONO2? Or excuse me, what type of group was NO2? Yeah, there's only one spot left that can be occupied, and that is this one, okay? Because if you did, oops, I did that backwards. If you went the other way around, if you added these first, okay, there's no way to get that methyl group on there. And when that NO2 is in excess, that means that just keeps on going until all spots have been used up. Now, you might be telling yourself, well, why can't we keep on adding something else? Well, these are already occupied, and what's on the ring is telling you where something can bond. You can't put anything here anymore. You can't put anything here anymore because you could say the geometry doesn't allow it because of where these spots are already occupied. So what we are saying here with the same reasoning is that this just keeps on going just like that nitric acid does. So it goes through what we call stage 2, and then that double bond and oxygen's still there, but now it causes an OH group to attach onto there. So in stage 1, we form what's called an aldehyde. And then in stage 2, we form what's called an acid. Okay. Okay, I had it in my mind, I had this book out that we were going to read through this together. I think for all practical purposes, now that we've seen this, okay, look at page 390, okay, and then when we're all back together, then we're going to read through that. Because when you look at the top of page 390, what do you see written in big letters in blue? Okay, on top of the arrow, sorry. Stage 1. And then what do you see written in red above the arrow? Of course, stage 2. So that is illustrating what's happening is that when you have primary alcohols, when you oxidize them in stage 1, you form an aldehyde. This oxidizing agent is so powerful, it just keeps on going, and it oxidizes one more time in stage 2 to form an acid. Okay, I think that's enough for today because that's really some higher order thinking. Maybe we could have adapted what we're doing today a little bit, but I just had it in my mind to keep plowing forward with this. And last thing, get your charts out really quickly, if you would please. And if you all get them out, that's fine, but otherwise just one of you can speak for the rest of the group. Okay, so therefore what we're looking at is, okay, here's one of our reactions here, okay. We have talked about that one, but and then here is our ether formation, but then there should be another side to that. Yes, okay. So whatever page you would want to call that, notice it says oxidation of primary alcohols. It goes through 2 stages. It's written in green, I believe. So that's what we're illustrating there, okay? Now, with secondary alcohols, they just get oxidized into ketones, and then their reaction stops. But we just wanted to go through them, perhaps the more difficult one, and we'll pick up with this tomorrow. I'll catch up to you next time. Is there an outro that we should do, Mr. Wagner? Okay, I think we're under the gun right now. I can hit pause here for just a moment.
Banana.